Hello everyone, my name is Tushar Singh and today I'm going to show you a very simple example of linear regression through a very small data set like this, which only contains two columns, hours and scores. So hours indicates the study hours for any particular student and scores is its corresponding scores based on how much hours that student studies. Okay, so I'm going to create a simple linear regression model based on the that data set, and later I've used that regression model to predict the value of a dependent variable based on a particular independent variable. So let's start this. So let's first import some very basic libraries like pandas, numpy, and matplotlib. Then let's load our data set. Now let's check the first five observations of our data. Okay, now let's see the shape of our data set. So our data set contains 25 rows and two columns. Now let's see if our data set has any missing values or not. So we can see that our data has no missing values. That means our data is clean and we don't need to perform any imputation or any kind of data manipulation techniques to clean our data. Now let's import statsmodel.api package. So statsmodel.api basically uh, import the majority of the helper function of statsmodel library, which we can use in our code later. Now let's segregate our data into two variables. So x being as the independent variable is this study hours, and y, which is the dependent variable, contains scores corresponding to that study hour. Okay, so let's see the current relationship between x and y with the help of a scatter plot. Okay, so in this scatter plot, you see that there is a linear relationship between x and y. X is our indicates the number of study hours, and y is the scores, which also means that there is a positive correlation between these two variables. Now let's add a column, which is a constant column, which contain only ones. And why I'm doing this is because I can use that uh, variable x1 as one of the inputs for our linear regression model, which I can use to calculate the value of slope. So this is basically the main purpose of this add constant is to calculate the value of slope, which you can use to predict the value of for any dependent variable. So let's now see the contents of x1. Okay, so as I already mentioned that x1 contains a new column which contains only one, okay, which we can use to calculate or find the value of a slope later. So, but if the thing is that if our data has uh, already has a constant value, then in that case we don't get any constant value like this once. In that case, this add constant doesn't do any kind of function relevant to our data set. Now let's create our OLS regression model and then train the model using fit. And okay, now and then place that in a new variable drag. Now let's see the summary of our regression model. Okay, so here we can see there are a lot of summary. So the first one is the R square value, which basically means that how much our independent variable can explain the dependent variable. So here in this case, we can say that our uh, independent variables are capable of explaining our dependent variable with a accuracy of 95.3%. Now, in the below section, we see that there's a coefficient value. So 2.48 here indicates our intercept, which is y-intercept, and 9.77 indicates our slope value. And its corresponding standard error means the range in which this value can vary. So 9.77, which is the R value, which is the slope value, can vary between 9.77 minus 0.45 to 9.77 plus 0.45. So it's a basic standard error that is allowed for this slope value. Now this is the p value, which is 0, as you can see, uh, which is a good thing because it is less than 5%, which means that ours is statistically significant with our dependent variable, which is scores. And this is the confidence interval, which is in the range of 95%, 2.5 to 97.5%. And the same result we can also obtain through SciPy, which is scientific Python. So let's import stats helper functions. Now we can also obtain the same result by using stats.linregress and input the independent and dependent variable x and y, and store the output of that linregress function in five different variables: slope, intercept, R value, P value, and standard error. Okay, so let's first check the value of slope. So our slope is 9.77, which is exactly similar to this. Now let's check the value of intercept, which is 2.48, same as this. Okay, so let's check the value of R, is 0.97. Okay, so the value of R square is 0.95, which is similar to this value. And then now see the P value, which is in scientific form 9.13 times of e raised to minus 17. Now let's see the standard error, which is 0.45, which is similar to this. So this confirms that our regression result is same as what we got from linregress function, and also higher R square value. Now here in our case is 95.3%, indicate that our regression model is an optimal one. Ideally, the minimum value for R square should be 30%. So if any model R square value is below 30%, that means that model is not an optimal one, and it's not going to predict the right value for the dependent variable. Now finally, let's predict the value for our dependent variable. So now I'm going to predict the score value for its corresponding x value. Now x value here is 9.25. Our slope value is 9.77, I think. Yes, 9.77, and our beta value is 2.48. Now it's a simple equation of line y is equal to mx plus c. Y is our score, which we want to find. So our score is 92.8, which is around 93 for the R value of 9.25, which means that if a student study for 9.25 hours per day, then his or her score would be 93. Now let's create the best fit line, which is nothing but the slope times of x plus intercept. Right, slope and intercept we already know. slope is 9.77, intercept is 2.48. All we have to do is to plug the values and we will get our best fit line. Now let's plot our best fit line. Okay. All right. So as we can see that the best fit or the regression line is tightly coupled with our actual observations. So actual observation basically is the ground truth values, which means that our regression model is very optimal model and there are no means very minimum amount of residuals. So the difference between the best fit line and the actual values indicate the residue or the error. So residual can be positive or can be negative. So here in our case, we see that uh, mostly our actual values and our predicted values, you know, similar to each other. That's why there are no residual values. So this is all about simple regression model and how we can use to predict the value of any dependent variable y. So I hope that you enjoy this very simple demonstration how we can use regression as a very powerful predictive modeling tool and forecast any variable based on that. And once again, thank you Sparks Foundation for providing this wonderful opportunity to learn and enhance our skills. And once again, thank you very much.